Good day. I am Dr. Faith Beta, working for the ARC Onderstepoort Veterinary Institute, based at the Transboundary Animal Diseases Campus. We work there with foot and mouth disease and other transboundary animal diseases. So as you know, the Onderstepoort complex was built in 1908. So it is over 100 years old. So because of that, the vaccine production process that we use became outdated owing to the old facility, but also because of the old production technology. So in 2006, the ARC took a strategic decision to embark on research of developing new production technologies using also new virus isolates of the FMD. So to that regard, they hired international contractors that worked in close collaboration with the ARC researchers to develop this new process of vaccine manufacturing. And that culminated in this auspicious moment of today, releasing the first 12,000 doses of the FMD vaccine, which is locally manufactured since 2005. So what has been the road to this milestone is that after these international contractors left, the ARC embarked on itself to work up on the scaling modalities of this production process. So to prove the concept of production, we bought bioreactors which were up to 20 liters. The reason for that is that the current old facility is capacity restrictive. It was not designed for the new process of vaccine manufacturing. So to that end, we proved concept by first employing new graduates who we would train in this technology. As we may know, in South Africa, vaccine manufacturing is amongst the scarce skills the country or shortages the country is experiencing. So we employed graduates and trained them in this new method of vaccine production, thereby building capacity, transferring skills, and showcasing the capacity of the ARC scientists. We proved concept, and by so doing a lot of animal studies. I may go back to say that the virus of foot and mouth is isolated from the lesions that cause the disease. One could ask, how do we get foot and mouth? So in South Africa, we have a population of buffaloes, which are among the big 5 in the country. And these buffaloes are the natural host of the FMD virus. And by getting into contact with cloven-hoofed animals, which are split hoof, your cattle, sheep, goats, and pigs. So by getting into contact with these domestic livestock, buffalo can transmit the virus to the livestock. Buffaloes live happily with the virus. You never see them get sick. However, when domestic livestock gets infected, you see lesions, erosion of the tongue epithelium, and animals get very sick, with young ones sometimes die from the diseases. So in that regard, we always in South Africa need FMD vaccines, in a sense that we cannot kill the entire buffalo population. It's part of our big 5, we appreciate that. So, but we need to protect our domestic livestock because we are also a very meat-eating society, and we use cattle for ceremonial activities as well, lobolas and all that. So we also need to protect these animals from the disease. So in that regard, we have developed a vaccine starting from what we call process development in technical terms. By product development, clinical studies, and then thereafter, we register a product. So what we have done since 2013, we have established through small animals what we call preclinical studies, where we would show that the virus that we have isolated and taught to grow outside the body of an animal. So by that, I mean we have created, not created, we bought bioreactors, which we grew cells in and then infect those cells with the virus of foot and mouth. And were able, through various scientific studies and our research, to grow this virus into up to billion virus particles. From there on, we needed to make this virus non-infectious so that we can inject it into an animal, but the animal doesn't get sick. It just recognizes that, oh, this is a virus. I need to make an antibody protection against that. And in that, when that animal gets into contact with the virus, then it doesn't get sick because the animal remembers that, oh, I have seen this particle before. I will compare it to the flu vaccine that we take. We take flu vaccines every autumn to prepare ourselves for winter. And that the vaccine doesn't make us sick, but it helps us to prepare ourselves in an event we get contact with the flu virus. So in that case, when we eventually get in contact with the virus, we don't get as sick because the body remembers the virus and say, I've seen this before, and it mounts a protection against that. So getting back to our FMD vaccine story. So as mentioned previously, we employed new scientists. We trained them up to master's degree, some to PhD level in vaccine production methods. It is to be said that because foot and mouth disease is very, very contagious, it requires specialized buildings as well, containment buildings, what we call biocontainment level 3 buildings, including even animal facilities. So because of that, our researchers are very specialized researchers. They have skills that you would not be able to pick out of the market easily. So we have developed a very good crop of scientists that will be able to work in manufacturing this vaccine going forward. As mentioned, what we developed was just to prove concept of efficacy of the vaccine, and that we have achieved through testing the vaccine in cattle. Cattle being the target species that we would vaccinate the animals against FMD for. So in that regard, our vaccine was shown to be very potent. And by potent, I mean that it allows the body to mount a very strong immunity against the virus that can last up to a year after vaccination. So we have shown those studies, and hence, if you were doing calculations in your mind, you would recall I said we stopped, the ARC took a strategic decision to stop the old way of vaccine preparation in 2006, and we are now in 2026. So 20 years it took. But the 20 years is explained by that. We get a virus from material, clinical material of an infected animal, and we teach it to grow outside the body in very large quantities so that we can make vaccine in large quantities. But our facility does not allow that at this stage. So hence today we can only release 12,000 doses. It's just based on capacity. And there is no way we can introduce larger production infrastructure into the existing facility, because of good manufacturing practices that are a standard in the production of biologicals, and anyway, because the facility is not designed for this process at this stage. So what we have done through this proof of vaccine production concept is having these antigens that we had banked and have now formulated into a vaccine that the government can now use. And it coincides, I don't know if one can never say it's luck or I don't know, maybe divine intervention, that the country is currently facing outbreaks that are ravaging our country. And because previously we were not producing the vaccine at large capacity ourselves, we were importing it from our neighboring countries. And they also now have challenges in providing us. You would recognize that every country prioritizes itself first. So when our neighboring countries have crisis, they will prioritize their need over us. So we are at a point that the DG and the minister approach us and say, can you make your vaccines available? And we were so very happy about that, in the sense that as you would have seen during COVID times, that SAPRA, which is a part of the Department of Health, regulates vaccines usage in the country, medicines and related substances. In the agriculture, we have a similar structure which that regulates the use of animal preparations, being feed, vaccines, and any drugs that relates to animals. So we were very happy that our vaccine was registered in 2022 as a stock remedy. So in that case, we don't have to go through requesting special dispensation to roll out the vaccine. So when the minister made the call, we were happy to say we can formulate the vaccine and make it available. We recognize at this stage is still just 12,000 doses, but it's a start and a milestone for the ARC, in a sense that the fruit of the past 20 years can now be seen in this. And this huge achievement has made the ARC in 2022 as well to employ project managers, architects, and engineers experienced in built environment to help the ARC design a new factory that will be able to host this new vaccine process that we have developed. This new factory will not be capacity restrictive. It has been designed to be able to produce vaccines of up to 20 million doses of vaccine per year. So soon we will be vaccine reliant. We won't be relying on importing the vaccine. We have the skills and we will have the facility that will host us. And in that light, we will be able to respond to any amount of vaccine call. I would say that a while back, when our president was inaugurated, he called us and said, Tuma Mina. And the ARC is proud today for raising its hand and say, yes, President, we will. In also, excuse me, our national anthem, we say at the end, sounds the call to come together, and united we shall stand. And in my experience, I have come to realize that this call can be any form of call. Sometimes challenges like the FMD outbreak the country is facing, which is putting so much strain in farmers and their livelihoods. But through this gesture of the ARC, we have honored the call to come together. We have raised our hands and said, President, here is some vaccine that you can use in the meantime. We understand and appreciate that for now it is limited, but we promise soon we will be able to be self-reliant and we will move away from importing vaccines because we, the ARC, have developed the process, the capacity, and the skills to be self-reliant. And this is a huge achievement. Thank you.